We're going to continue with right triangle trigonometry here in our 13.2 unit circle section. At the top here I've got a reminder of what sine, cosine, and tangent stand for here. It's our good old friend SOHCAHTOA. Hopefully you remember that from geometry last year. When we do this, make sure you understand you're working with a right triangle. And I want to show you how it relates to the unit circle. So to do that, I'm going to go to website here and show you a unit circle right here. It's a unit circle means it has a radius of 1. So here's my unit circle, radius of 1. And look what I have in the unit circle. I have a right triangle inside the unit circle. Now, unfortunately, I can't draw on this thing, so it's going to be hard to explain or point things out. But what I want to impress upon you is that when I move this point, this green point on the outside of the unit circle, I start moving it down to the right. Look what happens. The side that's opposite of my angle, and the angle is, hopefully you can see it's marked there. It's right next to the origin, right above the 0.755 right now. When I change that angle, when I make that angle smaller, my opposite side of that right triangle gets smaller. But the base side gets larger. If I go the other way, the opposite side gets bigger, and the base side gets smaller. Well, those are lengths. The base right now is 0.695, and the height is 0.719. But you can also think of them as the coordinates of the green point. So right now my arrow is pointing at the green point. I would say the coordinates of that are 0.695, comma, 0.719. It's based on my right triangle. It's 0.695 right and 0.719 up. Well, if you look up above, you'll also see that the sine, cosine, and tangent are listed. And you should notice that the sine and cosine are exactly the same as the lengths of the legs of the triangle. So what that implies is not only is this point, this green dot right here, that point, not only does that have an x and a y, not only do the numbers stand for the x and y, but those numbers also stand for the sine and cosine. What do I want you to get out of this? Sine goes with the y coordinate. So right now the y coordinate is 0.97, and the sine would be 0.97, because if you do opposite of hypotenuse, you do 0.97 over 1. Important to remember the hypotenuse is 1. So sine down here 0.8 or 0.799, changing now. If I go this way, that leg is getting bigger and bigger and bigger. Right now that leg is 0.96, 0.97, 0.974. Well, if I put that over 1, I'm going to get closer and closer to 1 until finally, if I do a 90-degree angle, which looks like this, I find out that the sine is 1. That's the biggest sine I can get is 1. If someone ever told you that the sine of an angle is 2, you'd say, no way it isn't. The biggest it can be is 1. Well, what you're going to find out is that on a unit circle, direction matters. Placement in quadrants matters. If I go the other way, so that I'm going negative 90, or I'm working my way towards negative 90, or positive 270, you find out that sine is negative 1. So sine goes with the y coordinate. This point down here, the green dot, if I would say what are the coordinates, hopefully it'd say it's 0, negative 1. That would mean the cosine is 0 and the sine is negative 1 of a negative 90-degree angle. One more thing to try to show you here. Let's go to where, there we go. Sine is 0.5. See how sine is 0.5? And if you look up top, it says that's a 30-degree angle. And the cosine is 0.866. Well, watch this. If I go over here, and I get sine of 0.5, and cosine is negative 0.866. I get the same thing, except for cosine to be negative. Cosine goes to the x. So when you're talking cosine and you're in these to the left in the second quadrant, you're going to get a negative. Well, that's for a 150-degree angle, which might not impress you too much, but if you understand that it's 30 away from the 180, you might go, oh, that's kind of cool. This angle that's between my hypotenuse and the x-axis is a 30-degree angle, because 150 plus 30 is 180. If you're 30 degrees away from the x-axis, you end up with the same sine and cosine, at least their absolute value, I should say, but the sines, the SIGNs, might be different. What's 30 degrees this way here? Well, that would be 30 degrees less than 360. That would be 330. And get there, come on. Oh boy, I'm having trouble. I can do this. One more, come on. There we go. And you see that we got negative 0.5 and positive 0.866. The same numbers. What's 30 away from this part of the x-axis? Well, that would be 210. 180 minus, or 180 plus 210. And you can see you get the exact same absolute values right there. Sine is negative 0.5, cosine is negative 0.866. You get the same numbers for your x and your y, just with different signs. Okay, so let's see how if we can put this knowledge to use. Basically what I'm saying is sine goes with y, so sine is positive when you're in the first and second quadrant. Cosine goes with x, so cosine is positive when you're in the first and fourth quadrant. Okay, sine's negative down here because when you go down on the y, that is negative. So down on the y-axis is negative. What do I want you to get out of that? Well, since the largest side of a right triangle is 1, that the sine and cosine can't be bigger than 1 because it's a ratio. You know, if I said, hey, draw a 90-degree angle, and I said, we'll call it theta, here's an angle right here, and let's find the sine of that. You said, I want it to be 2. That would mean that this would have to be 2, and that the hypotenuse would have to be 1. How are you going to get that to connect? How are you going to get that to connect? It's not possible. This over here has to be less than the hypotenuse. Now they will let you make it equal to hypotenuse to find a sine, meaning that the sine of 90 is something, which is 1. So what do I want you to get out of this? I want you to get basically that if I ask you for sine of some angle, and this is a theta symbol, we'll use that for angle all the time, that your answer is going to be between negative 1 and 1. Same thing for cosine. Somebody says the cosine of something is negative 10, you say, no it isn't, can't be. Okay? Alright, let's move on down. All I have here is just a reminder then of where is sine positive, where is sine negative. Sine goes with the y. Sine goes with the y. It's siney, it's not tiny, it's siney. And the y is positive in the first quadrant and in the second quadrant. Sine is negative in the third quadrant and fourth quadrant. Now, I don't like the way I wrote this. This isn't like meant to be like an x and a y where you've got coordinates, because I'd have it backwards. Cosine goes with the x, sine goes with the y. So if I wanted you to write point as a chord-ordered pair, write an ordered pair down, you do cosine comma sine. Okay? Sine goes with the x. So we got cosix. And trying to make an adjustment here, not having much luck. There we go. So cosix. And where is x negative? It's negative over in the second and third quadrant. Positive elsewhere. Oh, let's find tangent. What the heck? What's tangent then? Is tangent positive? Is tangent negative? Might as well finish it off and take care of the whole SOHCAHTOA here. Well, to figure out if tangent's positive or negative, here's a fun fact for you. Tangent is sine divided by cosine. So up here I can do a positive divided by positive is positive, so tangent's positive. Quadrant 2 I can do positive divided by negative is negative. So tangent's negative in quadrant 2. 3 I got negative divided by negative is positive. And quadrant 4 negative divided by positive is negative. So tangent is negative in quadrants 2 and 4. I'll prove that right here. I said sine is opposite of hypotenuse and cosine is adjacent to hypotenuse. Here I'm trying to divide fractions. To do that, I multiply by the reciprocal. And hopefully you're going, oh, you can cancel h's. And that leaves you with an O on top and an A on the bottom. And that's tangent. Tangent is opposite over adjacent. TOA. Some important values are 30, 45, 60s. The trig functions, the SOHCAHTOAs of 30, 45, 60. To help us calculate those, I'm going to remind you of your 30, 60, 90 triangle and 45, 45, 90 triangle. So I'm going to call this one 45. And this one will be my 60, 30. The pattern for 45, 45 is simply x and x. It's an isosceles, so those got to be the same. You got two angles that are the same, so it's isosceles. And then the other one has to be x root 2. I said it has to be because you can apply the Pythagorean theorem to that and show that 1 plus 1 is 2. Over here, short side's x, hypotenuse is 2x, and down here it's x root 3. Again, to show that works because 1 squared plus square root 3 squared equals 2 squared. You have 1 plus 3 equals 4. So you can always make sure you've got them right by running it through the Pythagorean theorem in case you were a little confused or not quite sure if it was square root 3 or square root 2. All right, how does this help me? If I want to find sine of 30, I say, hey, look, I've got a 30-degree angle right here, and I know sine is opposite over hypotenuse. Well, the opposite of 30 is 1x. The hypotenuse is 2x. X's will cancel. Sine's a half. Cosine of 30. Cosine of 30 right here is adjacent, which is x root 3 over hypotenuse, 2x. X's cancel. That's square root 3 over 2. Tangent of 30 would be opposite. So here's my 30. Opposite, 1x over adjacent, x root 3. X's cancel, I get 1 over root 3, which you shouldn't leave. You should change that to square root 3 over 3. Rationalize the denominator. 45. Here's a 45. Sine would be opposite, which is 1x, over hypotenuse, which is x root 2. X's cancel, you get 1 over root 2. Multiply top and bottom by root 2 on that one. And that simplifies to root 2 over 2. Cosine, same thing, because you're going to do adjacent over hypotenuse. You got the same thing there, root 2 over 2. Tangent would be x over x, which is 1, or you could do sine divided by cosine, which is 1. Cosine, sine of 60, sine of 60. I'll start over up here. This was my 60. 30 was over here, but I'm looking at my 60. It went x, it went 2x, it went x root 3. Sine of 60 would be opposite over hypotenuse, square root 3 over 2. Cosine of 60 would be adjacent, which is 1x, over hypotenuse, which is a half. Notice that these two here just flip around. Okay, they flipped around over there. And then tangent would be square root 3 over 1, so square root 3. The tangent has the square root 3's. I choose to remember that the tangent of 30 is square root 3 over 3 because 30's got a 3 in it, so I'm going to have that extra 3. So that's kind of how I remember which one's square root 3 over 3 and which one's just square root 3. By the way, on the top here, I wanted to write down the radian measures. 30 degrees is the same as pi over 6 because 30 out of 180 is a sixth. Right? If you've gone 30 degrees, you've got 1/6 of the way to 180. So you've got 1/6 pi. Pi and 180 are the same thing. Pi radians and 180 degrees. 45, that would be 1/4 of the way. So that's pi over 4. And 60 would be 1/3 of the way. 3 times 60 is 180. So if you've gone 60 degrees, you've got 1/3 of the way. Okay, so I'm going to show you a little bit how we can use that data and what I've gone over here. I want to know how many angles are 30 degrees away from the x-axis. There are 4. There's one here. That was a little shallow. There's one here. There's one down here. And there's one down here. So there's 30 degrees, which is pi over 6. Then there's this one, which is 30 degrees away from 180. It's 30 degrees shy of 180, so that's 150. It's also pi over 6 short of a full pi. If I went pi over 6 more, if I went 1/6 pi more, I'd be at a pi. So that tells me that this must be the same as 5 pi over 6. 5/6 pi is 5/6 plus 1/6 is 1. Okay, next one. That's 30 greater than 180, so that one's 210. And that's 1/6 more than pi. So it would be 1 pi plus a 6th pi, which is 1 1/6 pi. And 1 1/6 is the same as 7 over 6. So this is 7 pi over 6. And then the last one is 30 away from 360. It's 30 shy of 360, so that's a 330. And it's 1/6 away from 2 full pies. So if I was 1/6 away from 2 full pies, that means I had 1 5/6 of a pi, which is 11/6. So that's 11 pi over 6. What's special about those angles? I'll just write the degree measures. So I got 30, 150, 210, 330. What's special about these angles? The sines, cosines, and tangents have the same absolute value. That's what's special. The sine of 30 is a half. Therefore, these all are going to be some form of a half. 2 of them will be positive, 2 of them will be negative. Where was sine positive? Up high. Sine's positive in the first and second quadrant. Therefore, it's negative in the third and fourth, because you're down low. Cosine of 30. Cosine of 30 is square root 3 over 2. So these all are some form of square root 3 over 2, square root 3 over 2, square root 3 over 2. Where's cosine positive? It goes with the x. So cosine is positive to the right. What's to the right? First and fourth quadrant. First and fourth quadrant. Okay? So it's negative in the second and third quadrant. Tangent. Tangent of 30, that's the one with all the 3's in it. So it's square root 3 over 3. 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 And where's tangent positive? Where's it negative? Tangent's positive in the first quadrant, because remember you can do sine over cosine. A positive divided by a positive is positive. Second one, positive divided by negative is negative. Third one, negative divided negative is positive. And the last one is negative. So that's how I can use my chart on the previous page and the knowledge of where is sine and cosine positive negative to come up with exact values for the trig functions of these angles. I've basically got two more of the same thing here. I guess it's getting to be kind of long, 20 minutes. I'll run through one more here. And the last one I'd have you do on your own, and you can check with me if you did it right or not. So I want a 45-degree angle. How many of them are 45? There are 4. 1 in each quadrant. What are they? Well, you got the 45, which is pi over 4. Then the next one is here. That's 45 short of 180, which is 135 degrees. It's also pi over 4 short. So this is the 45 right here, which is pi over 4. Is pi over 4 short of a whole pi. So that's 3/4 pi. This one is 45 more than 180, so that's 225. It's also a 1/4 pi more than a whole pi. So that's 1 1/4, and 1 1/4 is 5/4. So that's 5 pi over 4. Last one, that's 45 short of 360. 360 minus 45 is 315. It's also a 1/4 short of 2 full pies. If I take 2 pies and I subtract a 1/4 of a pie, I have 1 3/4. Now 1 3/4 is 7/4, 7 pi over 4. Okay, so I'm just going to list the degrees again. We'll do sine, cosine, tangent. Sine of 45 is √2 over 2. So these are all going to be some form of √2 over 2. Where is sine positive? First, second quadrant. It's negative in the third and fourth. Cosine of 45, that's also √2 over 2. But cosine is negative in a different spot. It's negative in the second and third. And then finally, tangent is going to be some form of 1. Where is tangent negative? Second, fourth quadrant. So that's the idea. I found basically, I didn't even use the word yet, but I found these angles that have what's called the same reference angle. Here 45 is the reference angle. You're 45 away from the x-axis. And up above there, I was 30 away from the x-axis, so that was the reference angle. You can use reference angles to come up with sine, cosine, tangent of angles that are larger than your 0 to 90s. So again, I would have you try to do the third one on your own. You can check with me to see if you got it. Thanks for watching. Have a great day.